Hello, students. Today we're going to be talking about reciprocal identities. Actually, we'll be talking about four different types of trig identities, but the first is reciprocal identities. And we've actually talked about these before. So the reason we're learning these trig identities is we are going to start simplifying different expressions. We'll be proving and verifying identities. And eventually we'll be solving trig functions. Most likely in pre-calc or SAM, due to the distance learning here. Okay, so let's just first talk about our reciprocal identities. So we've talked about these before. So remember our 6 different trig functions. We have sine of theta, and write these down. It's really helpful if you guys make some sort of a chart or a sheet that has all of your identities together. So make sure you're taking notes. So to get credit for this assignment, I do want you guys to upload your notes to Google Classroom as well as do the 5 different problems on the Google form. Okay, so we've got sine of theta. Remember cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Okay, so reciprocal, remember, when you think of reciprocal, what do you guys think? We could have a discussion if we were in class. So remember, reciprocal to me, I think, okay, it's 2 expressions that if you multiplied them together, they would equal 1. So essentially, the numerator and the denominator flip when we think of reciprocal. So for sine is actually 1 over cosecant of theta. We've talked about this before. So cosecant of theta, we can also rewrite this as 1 over sine of theta. Cosine of theta, we can rewrite that as 1 over secant of theta. Secant of theta is 1 over cosine of theta. Tangent is 1 over cotangent of theta. And cotangent is 1 over tangent theta. Remember, theta is just that variable we use when we're thinking about an angle measurement. The way that I like to remember these, I've told you before, but each pair has one c. So with sine and cosecant are a pair, so c for cosecant. Cosine and secant are a pair, so c for cosine, and then tangent and cotangent are a pair, c for cotan. I've also heard other people remember sine and cosecant. There's one of them that has an S, the other has a C, and then cosine and secant as well. It's a C and an S. We never pair S and S or C and C. So I don't know, whatever way you remember them. For me, if you write them down, the more you do it, you'll remember it. By next year, you got this. All right, so it's nice we know these. So now what we're going to do is we're actually going to do an example in which we need to verify an identity. So I'm going to scroll down here. So I'll call this example 1. All right, so verify the identity. So, and the problem is secant of theta times cosine of theta equals 1. All right, so when it tells us to verify the identity, what I need to do here is, well, we've got a list of identities. So remember, identities, they're equivalent expressions. So we can use them interchangeably when we're verifying this identity here. So it's an identity because we've got 2 things equal to one another. Secant times cosine is the same as 1. So when we're doing these problems, I love it. It's like a puzzle. We've got all of our pieces to the puzzle are those identities that we just talked about. Now we're gonna swap out some of the pieces for a different piece to try to make an equivalent expression, an equal expression, in which I have the same value on both sides of my equal sign. So my tip here, always start with the more complex side and make it more simple. So we have secant times cosine, which is much more complex than 1. So I'm going to start there. So looking at my list of identities that we just wrote down, I know secant of theta is equivalent to 1 over cosine theta. So since the first time we're doing this, I am going to just make a little box over here on the side. Identities that I used for this problem. So for me, the helpful identity, or you might call it like your toolbox or something, is secant of theta is equal to 1 over cosine of theta. Now, you may have a different idea because cosine of theta is 1 over secant of theta. So it's really important to know that the way that we verify these, there's not one unique way to verify identities. There are many ways, especially we're going to learn a lot more identities. So really, I mean, there are multiple ways that you can solve these. So for this one, I would just say there's 2 based on what we know so far. So I'm going to solve it one way, but keep that in mind when you're doing your work and you look at my examples, because your work may be slightly different than mine, and that's okay. We want to be different. We don't all want to do everything exactly the same. That'd be boring. Okay, so secant of theta, back to the problem, times cosine of theta equals 1. So I'm simplifying the complex side using my identity that I wrote there in my box. So instead of secant of theta, I can interchange this. I can replace this with 1 over cosine theta. So 1 over cosine of theta times cosine of theta equals 1. All right. Remember, our end goal is to make this left side equal 1. So remember, cosine of theta, I can just rewrite that as over 1. Any expression, we can just set it over 1 and it's still equivalent. Now I've got 2 fractions to multiply together. So remember, we multiply straight across. 1 times cosine of theta is just cosine of theta. And then the denominator, cosine of theta times 1 is cosine of theta, all equals 1. Anytime we have a value over itself, cosine over cosine, it's just 1. So 1 equals 1. When I get done, I always like to put a check mark just because so that I know I'm done. That's just preference for me. But sometimes when we get into more complex problems of these, you might try it one way and then you have some sort of an error, you don't get where you want to go. So that's why it's important that you stay working on one side at this point. Some people, you could work on both sides, maybe dividing by secant or dividing by a cosine. But then, like I said, like right now, we're working pretty basic and simple. So for these problems, it would be okay. But when we get into doing proofs, you are only allowed to work on one side. And for me, it's easier to see kind of the flow if you're only working on one side. Because sometimes we're going to get into problems that have like 10 steps to verify identities. So stay working on one side. Try it in the next example.